Hello, my wonderful advanced algebra students. And now for part 2 of worked examples from our practice test number 5A. We're going to be factoring the polynomials completely. Remember that we have 3 different methods that we learned in section 5.4. We learned factoring by grouping. We learned factoring polynomials that are in quadratic form. And we learned the formula-based factoring for the sum and difference of cubes. But let us remember before we do any of these that we should always factor out the greatest common factor. Looking at 12 and 13, there are no common factors in all of the terms. However, in number 14, we will notice that there is a common factor. So let us go ahead and factor out the 2. Putting the 2 on the outside of a single set of parentheses, we are left with w to the third plus 27. Now looking at that, that is a sum of cubes. We will get to that in just a second. Let us go back up to number 12. This is of quadratic form. How do we know? We see only 2 terms. It reminds us of a difference of squares. Using a simple substitution, y is equal to x squared. Therefore, y squared is equal to x to the fourth. Substituting in y squared for x to the fourth, we now have y squared minus 16. This is the difference of squares, and we factor y plus 4, y minus 4, as we have done many times before. We now substitute back in for y. We notice that y is equal to x squared. And we have x squared plus 4 and x squared minus 4. We must always take a look and see if the sets of parentheses that we have can be factored further, as our instructions are to factor completely. So, we notice that x squared plus 4 cannot be factored. It is a sum of squares. Sum of squares cannot be factored further. However, x squared minus 4 is a difference of squares, and it can be factored further as follows. Okay, number 13. This is factoring by grouping. We're going to factor out a common factor from the first 2 pieces, and then again from the second 2 pieces. Again, our hope is that what it remains after we factor out a common factor is the same thing in the 2 sets of parentheses. So from the first 2, we factor out a 9m squared. What remains is m plus 2. We do the same thing for the second 2 terms. Let us factor out a negative 4. What remains is an m plus 2. Remember, the idea there is to get the m plus 2 in parentheses. If we had factored out a positive 4, we wouldn't have been left with an m plus 2 in parentheses. Let us factor again. Factoring out the m plus 2, please note that the m plus 2 is in common to both terms. We have a first term at the beginning, and we have a second term at the end. M plus 2 is in both. What remains when we take out the m plus 2 is 9m squared and a minus 4. Okay, we notice that the second set of parentheses, just like before, can be factored again. 9m squared minus 4 is a difference of squares. It is 3m plus 2 and 3m minus 2. And that's our answer. factor completely. Remember, we are not guaranteed that the second set of parentheses will necessarily factor every time in this. In this case, it does. Down to our sum of cubes formula, we have 2 times one set of parentheses times a larger set of parentheses. Our job is to determine what are A and B from the formula. You can look up the formula in your notes. In this case, A is equal to W and B is equal to 3. W is the cube root of W to the third, and 3 is the cube root of 27. Using these in the formula, we get W plus 3, W squared minus 3W plus 3 squared, which is 9. And this is our final answer. Let us consider problems 15 and 16 here about end behavior. So we write as x approaches infinity, that's the proper notation. We want to know what is y doing. We also want to know what is going on as x approaches negative infinity. What is y doing? Let us remember that as x approaches infinity means what's going on the far right-hand side of the graph. As x approaches negative infinity is what is going on the far left-hand side of the graph. Let's write the same notation over here on the other side. Problem number 16. We want to put in either a positive infinity or negative infinity. We have a leading coefficient of negative 3. That means that we end negative. This is a quartic, so the graph is going to look like an M. Therefore, it is ending negative. Therefore, on the far right-hand side of the graph, y is approaching negative infinity. On the far left-hand side of the graph, it is also approaching negative infinity because we have a quartic. For number 16, we have a quintic that's an odd degree and a positive leading coefficient. Therefore, the graph looks like as follows. It has to end positive. It turns around a couple of times in the middle. And therefore, on the far right-hand side, as x approaches infinity, y also approaches positive infinity. Since it is a odd degree, it will start in the opposite direction. On the far left-hand side of the graph, y approaches negative infinity. And those are our answers. Thank you.